Okay, the next thing that I'm going to talk about, folks, is what's called geometric isomers. It's a little bit different. Geometric isomers deal with, you must have multiple bonds. You must have, not multiple, it must be a double bond. So it's an isomer that deals with, deals with a double bond. And the fact that a double bond is very strong, and you can't really kind of spin on it, and I'll show you what I mean by that. If I have this carbon, 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 and I've got branches, we've talked about the fact that it doesn't matter if these are on up or down, because what happens is if you have bonds between two carbons and it's a single bond, okay, notice that if I spin my fingers, okay, it's easy to do. Okay, you can spin your fingers up, they're both up, now one's up and down, the bond just rotates. But if you have a double bond between two carbons, my hands are my carbons, and here's a double bond between, and here are some branches up on top, notice when I try to spin, I cross my bond. You see how it's, so this double bond won't allow it to spin like that. So there is a difference. A geometric isomer basically means if the carbon is on top or on the bottom. So here's an example. Double bond. Now these aren't branches. This would be hydrogens here, right? Notice this carbon can have 4 branches off of it. It has 4 bonds off of it. So here's one versus this, where the carbons are up or down. So notice these are both the same thing. They're both 2 butenes. These are 2 butenes. Because notice my numbering here again, I have 1, 2, 3, 4. There's no branches, right? It's just a long chain. 1, 2, 3, 4. Okay, so they're both 2 butene. But how do we differentiate? Because the top, this one on this left here, if I call this A and this one B, the one on the left, the carbons are both up. The ones on the bottom, for them to behave like that, it would have to be like this. You can't spin it. So it would have to behave like this. Yes?
Now, when both carbons are facing up, does that make it positive?
No, it's just a different arrangement. Yeah, no. No, but it does create some differences in how they bond with other things or how they react. Yeah, absolutely. So this formation on the left here, with them both being up, would be considered the cis formation. Cis, H-I-S, okay? This one on the right is also a 2, butene, but it's called the trans formation. Trans formation. On opposite ends, if by definition opposite ends. So opposite the double bonds. So cis means the same up on top of the double bond. This one means one is up, one is down. So cis or trans geometric isomers, just by definition, is that. Okay? So if you see something that has, grab a different color, carbon, carbon, double bond, carbon, carbon, and we have, like, let's say a branch over here and a branch down like that, what would that be, do you think? Cis or trans? Trans, because we've got our trans here. Okay?